So this will be our first of hundreds of lectures this semester. I'll try to keep them all at about a half hour each and break sections into multiple parts. Absolutely guaranteed that as we go through a video that I'm going to make a mistake, probably in every video, if not very often. If you see a mistake, just let me know. If it's a horrendous mistake, I'll re-record the video. A lot of times my mistake is I'll write the problem will have a +6 and I'll write a +2 because I'm thinking about what to say next and how to make my words flow together smoothly, and somehow what I'm writing isn't what I'm thinking at the time, and sometimes what's in my mind spills over into my hand and I write something that's kind of garbage. So just be prepared. There's going to be mistakes. Try to make these things as perfect as I can, but they're not always perfect. Let me just jump into problems 1 through 4. Problems 1 through 4 don't have any algebra. Each of the problems gives me a graph, and specifically it asks me to find an X-intercept and a Y-intercept, or it says find the X and the Y-intercepts. Well, when I have a graph, I should know that the horizontal axis is the x-axis and a vertical axis is the y-axis. And x-intercepts, or an x-intercept, is any point or each point or every point on the x-axis of the graph. So if I know what axis is the x-axis and I can identify all the points that are on the x-axis, I can figure out the x-intercepts without doing any algebra. Similarly, the y-intercept of a graph will be every point on the y-axis of that graph. So each of the first few problems I'm going to answer by inspection. I'm not going to do any algebra. So when I go to do problem 2, which is going to be my homework problem, I'm going to scan across the x-axis and look for every point on the x-axis. I mark the point 5, 0. That's a point. It's on the x-axis, so it's an x-intercept. And I mark the point 1, 0. It's on the x-axis, so it's an x-intercept. So when I go to answer problem 2, for the x-intercepts, I'm going to write the points 1, 0 and 5, 0. Sometimes you'll see teachers and students get lazy, and instead of writing the intercept as a point, they'll write it like an x equals. This would be not so good. It's kind of, I could live with it if you wrote x equal to 1 and x equal to 5 as the answer to what the x-intercepts are, but that's not really correct. Intercepts are points on graphs, and the graphs that we're going to do are two-dimensional graphs, and each point should have both an x and a y. So that's half of what I need to do for number 2. The other half is to find the y-intercept. And notice I'm writing down x and y-intercept because if you just randomly wrote points, I wouldn't know which points you wanted to represent the x-intercept and which points you want to represent the y-intercept. So to find the y-intercept, I'll look for every point on the y-axis. There's only one point on the y-axis. It's the point 0, -5. So for the answer to problem 2, the y-intercept is 0, -5. Occasionally you'll see somebody write an answer like this instead of writing it as a point. These are kind of not so good answers. These are kind of not really correct. I mean, I would understand if you wrote x equal to 1 and 5 what you meant for the x-intercepts. And if you wrote y equal to -5, I'd understand what you meant for the y-intercept. But if you're going higher in math, it's good to do the best possible answers, and those would be the best possible answers. I'm going to try as we go through the videos to always have your homework problem on the screen. So as I did problem 2, your problem 1 has the same instructions and it has the same skill. So you should be able to do problem 1, maybe pause the video and check your answer with my answers that I showed you in the introductory video. So 3 and 4, same style of problem, no really new comments I should probably make here. So as I go to do number 4, I'm just going to look at my x-axis, and every point on the x-axis is an x-intercept. So for problem 4, I'm going to describe or write my answer down, and I'm very specifically going to use the word because I'm finding 2 different intercepts, and if I just wrote the points down and didn't say these are the x-intercepts and this is the y-intercept, then it might be confusing to somebody that's grading. Notice I pluralized the x-intercept because there's 3 of them, and then for the y-intercept it's the point on the y-axis, which is the point 0, -18. That's everything for the first 4 problems. The next few problems are going to continue with intercepts, but they're going to not give us graphs. I give you equations, and you're going to be asked to find the intercepts without having a graph to look at. It's not particularly hard to do, but it's harder than just looking at a picture. So the next few problems, 5, 6, 7, 8, 9, 10, 11, and 12, the instructions say use algebra to find the x and the y-intercepts. And because I knew I was going to write this down, I typed it because my typing is infinitely better than my cruddy handwriting. So algebraically, to find an x-intercept, you let the y value in the equation be equal to 0. Your x-intercept will be written as a point. So let me start problem 6, which is my even problem that has the same skill as your problem 5, which is the odd problem you should be able to do when I finish this page. So to find x-intercepts, the algebra is to let y equal to 0. And just do the algebra that shows up, which means your algebra skills can't have gotten horrendous since the last time you finished a math course. So I'm letting my y equal to 0 and doing orders of operations. This 4 times 0 is equal to 0. And then the left-hand side, anything plus 0 is itself. So the left-hand side simplifies to 2x. I'll divide by 2. And get the number part of my x-intercept, which is going to be 6. When I go to write my answer, my x-intercept is going to be written as a point. There's going to be the answer from my algebra, which in this case is 6, 0. So part of my answer to problem 6 is the x-intercept is the point 60. That's half of what I need to do because I need to find both the x and the y-intercept. So next I'm going to find my y-intercept. And it says to find the y-intercept, let the x value in the equation be 0. Your y-intercept will be written as a point 0, y. The reason it's going to be 0, y is because I'm plugging in 0 for x. And when I write a point, it goes x first and y second. So algebraically here, I go to my equation, 2x plus 4y equals to 12. I change the x to 0, and I do my algebra. Eventually, I'll get lazy and say this is just going to simplify to 4y equals to 12. You never have to show as much algebra as I'm showing. So if you just wrote 4y equal to 12 after the line that has, after my first line, that's completely fine. You don't have to show quite as much algebra. Similarly, you probably wouldn't have to show all the algebra I'm doing here. If you can do some of this algebra in your head, that's a good thing. So I've done my algebra. I need to create a point. When I did my algebra, I let x equal to 0. So when I write my point, the x part of the point needs to be 0. And just staring at my answer, I could see that the y part of the point should be 3. So my answer to problem 6, if I was to graph this, it would graph to be a line. And the x-intercept would be 6, 0. The y-intercept would be 0, 3. 7 and 8, I often sneak on the tests. Same instruction, find the x and find the y-intercept. And students consistently lose points because they take square roots and they forget you need to do plus or minus. Let me just jump into this. So always, when I have instructions to find x and y-intercepts, I'm always plugging in 0. To find an x-intercept, you let y be 0. And when I go to write my answer, the second coordinate is going to be a 0 because the y is the second coordinate. So algebraically, I'm going to let y be 0. And anytime I'm replacing a variable with a number, I'm allowed to put a parentheses where the variable was. But I always don't have to. But if a variable has an exponent or a coefficient, when I do the substitution, I usually do the substitution with a parentheses. So when I had to let y equal to 0, I put a parentheses where the y was, put the 0 in a parentheses, and this is a safe way to go about substituting a value in for a variable. Now just orders of operations. On the left-hand side, 0 squared is 0, and I'm going to minus 16 from both sides. This is going to give me minus 16 equals to x. And when I go to write my answer, the x part of the x-intercept is negative 16, because it says x equals negative 16, and I see y equal to 0. So the x-intercept is going to be the point negative 16, 0. The y-intercept is where students choke on this. To do the y-intercept, there's two ways to do it. Maybe more, but two that I can think of right now. I'm going to let the x be 0. And you'll notice that when I let the x be 0, I didn't put the x in the parentheses. If you have a naked letter, meaning it doesn't have an exponent or a coefficient, when you're substituting, you don't need the parentheses. So letting x equal to 0, I get y squared equal to 16. So often students do bad things when they try to find the x-intercepts because they don't remember their algebra quite perfectly. If I introduce a square root to get rid of a square, which is one way to solve this problem, the side that has the constant I have to put a plus or minus on. When we have an equation that has a square, you expect to get two solutions as opposed to one solution. So one way to solve this is to square root plus or minus square root. The square root of y squared is just y. The square root of 16 is 4. This gives me two y-intercepts, or two y values for the y-intercepts. The y of positive 4 and a y of negative 4. When I go to write my answer, I should write two separate points because there's two y-intercepts. If I was to graph this, this graph would cross the y-axis twice. When I go to write my answer, I know the x-coordinate of both of the points is going to be 0 because algebraically I plugged 0 in for x. And the y-coordinates are going to be 4 for one and negative 4 for the other. This would be fine. Sometimes I write the word and between if there's multiple intercepts, but just writing the 2 points is fine. This is the dangerous way to get the y-intercept. There's an alternate way to get the y-intercept that involves factoring. Which is the safer way, but it means you have to remember how to factor. So Always to find a y-intercept, I let x be 0. So the first step in my alternate way to find the y-intercept is going to be the same. Similarly, my second step in my alternate way to find the y-intercept is going to be the same. Instead of solving with square roots, I could have set this equal to 0 and solved by factoring. So the alternate approach would have been to make this y squared minus 16 equals to 0. And then you have to have some recollection of factoring. This is about the most basic kind of factoring that we do. This is a difference of squares. And to factor a difference of squares, you divide exponents by 2, you square root constants, and you get two essentially identical parentheses, except one has a plus sign and one has a minus sign. So to factor y squared minus 16, because the y came before the signs, it's going to go in the first part of my parentheses, and it's going to turn into a y to the first power, and I'm going to suppress that exponent of 1 and just write a y. When I'm factoring differences of squares, one parenthesis gets a plus, another gets a minus, and what goes after the signs is what the 16 turns into when you square root it, which is a 4. Once I get it factored, I can get my answers of positive and negative 4 by taking each of the factors, separately setting each one equal to 0, and then isolating the y by either adding or subtracting the 4 depending on what's necessary. You have to remember how to factor for our class kind of regardless of how you solve this problem. And this kind of factoring, if you don't remember how to do it, if you looked at my intermediate algebra videos, this is where I teach factoring. This kind of factoring that I just did is my intermediate algebra section 1.5. So if you don't remember how to factor differences of squares, which is a super common factoring, take 20 minutes or so and watch the video for section 1.5 in intermediate algebra. It will show you, refresh your memory on this kind of factoring. So that's everything for 8. Maybe it's a little bit of overkill, but you don't have to solve the problems two ways. This is the easier way to solve the problem, but if you didn't do the plus or minus and only had one y-intercept when there's actually 2, you're going to lose some points on the test. So and you don't want to lose points for something that's not so hard. 2 more problems, and then we might get into a part 2. There's probably going to be at least 2 parts to this video, maybe more. So 9 and 10 want me to find the x and y intercepts. I don't know why I'm going backwards. Let me not go backwards. Let y equal to 0 to find the x-intercept. Let me start abbreviating intercept. So when I let y equal to 0, I'd get 0 equals to x squared plus 3x minus 4. This I'm going to solve by factoring. And in my intermediate algebra, if you don't know how to factor this is section 1.3, I would say part 2 of my videos. So if you don't remember how this is super basic factoring. If you don't remember how to factor something that's this basic, you need to relearn it. Go to my intermediate algebra class, watch the part 2 video of section 1.3. In order to factor this, because I need to solve it by factoring, when you have something that has a square and it's set equal to 0, factoring is usually the way that we solve. I'm going to create my 2 parentheses, and I'm going to split the x squared evenly between the parentheses by dividing its exponent by 2 and getting a couple of x's. After the x's, the numbers I'm going to need they're going to need to multiply to -4. One's going to have to be plus, the other's going to have to be minus, and they're going to have to add, it's really subtract, to positive 3. And those numbers are going to be positive 4 and negative 1. Because if you multiply positive 4 and negative 1, they multiply to that constant at the end, which is negative 4. And if you add positive 4 and negative 1, you're really subtracting. If you're adding numbers that have opposite signs, you subtract and take the sign of the larger. Those will add to be 3. So sometimes I say add, subtract. Sometimes I just say subtract. Sometimes I write add in quotes because you're not really adding because they have opposite signs. So into my parentheses to finish up my factoring, I get a plus 4 and a minus 1, specifically because 4 times 1 is minus 4, and 4 plus negative 1 is 3, or 4 minus 1 is 3 if you care. Now that I have it factored and set equal to 0, I can set the insides of the parentheses equal to 0 and isolate the x. Eventually, you shouldn't show all the algebra that I'm showing right now. This is overkill on the algebra. When I go to write my answer for number 10, there's 2 X-intercepts. They're negative 4, 0 and positive 1, 0. If you just wrote the points without the word and, I could hardly care. As long as you have the points correct and as long as the points are written as points. Very specifically, I made the y's 0 because the points always go x first and y second, and I made the x's what the algebra came out. So to finish up this problem, I'm going to find the y-intercept by letting x equal to 0. I'm going to leave the left side y, and then on the right side, for both the x's on the right side, I'm going to put a parentheses where the x was, and inside that parentheses put the number 0 because I'm replacing the x's with 0. Simplify, 0 squared is 0, 3 times 0 is 0, and I get y equals 0 plus 0 minus 4. That gives me y equal to negative 4. That's not good enough for an answer. When I go to write my answer, I'm going to write it as a point. The algebra says y equal to negative 4, so in the y coordinate of the point, I'm going to put negative 4, and then it says x equal to 0, so I'll write a 0 for x. So always when I'm finding intercepts, it's best practice to write your answers as points. So you should be able to do number 9. We'll do 11 and 12, and then we'll make a part 2. I'm sensing there's going to be 3 parts to this section. So number 12, first I'm going to find my x-intercept by letting the y equal to 0. I'll go x equals 0 squared minus 7 times 0 plus 10. I'd probably not even write anything down but the answer for the x-intercept because this algebra is easy to do in my head. If you write an answer down without any work, and it's something simple like this, I'll give you full credit on a test. But if you make a mistake, I can't give you partial credit. So very dangerous not to show any algebra. If you show algebra and you make a mistake, it can give you partial credit if the mistake is, kind of a trivial mistake. So I found the x-intercept by letting y equal to 0, did my algebra and got x equal to 10, wrote my answer as a point. Now I'm going to find my y-intercept by letting x equal to 0. And I'm going to solve this by factoring. Again, this is in section 1.3 of intermediate algebra. To factor this, I'm going to split the y's between my parentheses. And now I'm looking for double negative numbers because I need to get a negative into the problem to get that negative 7 that's between the y squared and the 10. And my double negative numbers need to multiply to 10, and they really actually add to negative 7. Here, when the signs are the same, you're really adding to get that middle number. So I say the numbers are -2 and -5 because if you multiply -2 and -5, the double negative multiplies out to be a positive, the 2 and 5 multiplies out to be 10. And if I add -2 and -5, if you're adding numbers and they have the same signs, you add the numbers and keep the signs. -2 plus -5 is -7. So in one of my parentheses, I'll get a -2, and the other parentheses, I'll get a -5. Once you have the problem factored and set equal to 0, you can get the answers by setting each of the factors equal to 0 and doing the algebra to isolate the variable. In this case, it's going to be adding 2 and adding 5. So that's the numerical part of my y-intercepts. When I go to write my answer, I'm going to write them as points. And I don't have really room to write the word and. This is fine. So I made the x part of my points equal to 0 because I let x equal to 0. I made one of the y's 2, the other y 5. So let's pause and move on to a part 2, and I'm pretty sure there's going to be a 3-part lecture to this section. So let's just pause right now. And if you're burned out, don't go further. If you're not, we can keep going on. It's a completely new concept in the second video. We're kind of done with intercepts for right now.